So if we're going to talk about the shape of the universe, we have to define what shape means. Like my table right here is flat, your screen is flat, but the Earth is curved, and a saddle, like a saddle that you use to ride around on a horse, is also curved. But how do we define it mathematically? Like, what is it about a sphere that makes it different than a table? How can we write that down in math? And the answer is looking at how parallel lines behave. So for example, if I draw on a piece of paper two little lines that are parallel, and I keep continuing those lines on a flat piece of paper, they'll stay parallel forever. They won't get closer, they won't get further away. But if I try this on the Earth, something different happens. Let's say you go down to the equator with a friend, and you're both on the equator, and you both have a little compass pointing north. And you both start walking north. Initially, you're parallel. You're the same distance apart. But slowly, as you get more and more north, even though you're both going in straight directions, you're not turning left, you're not turning right, you're just going straight ahead, eventually you'll bump into your friend, and that will happen at the pole. It'll happen at the North Pole. Lines of longitude, the uppy, downy, northy, southy lines on a globe, start out parallel at the equator and they end up intersecting. This is how we know that geometrically the Earth is curved. I mean, we know for lots of different reasons why the Earth is curved, but mathematically the definition of curved is that these two parallel lines will intersect. And the opposite is true for a saddle. Like if you start with two parallel lines on a saddle, they'll eventually diverge. They'll spread apart. So this definition works in any number of dimensions. A piece of paper, a surface of the Earth, the surface of a saddle are all two dimensions. Our universe is three spatial dimensions, but we can use the same definition. If I send out two parallel beams of light, like two laser beams, and I start them out parallel, I'm asking, when we're asking what is the shape of the universe, we're wondering, will these laser beams eventually intersect? Will they eventually spread out? Or will they keep on going perfectly parallel? Now, of course, there's all sorts of little bumps and wiggles in the universe. There's black holes, there's galaxies, there's clouds of gas and dust. Those are like local perturbations. Of course, if two parallel light beams start out parallel and they hit a black hole, they'll intersect inside of the black hole. That's local stuff. I don't care about that stuff. When you're doing cosmology, when you're looking at the universe at the very largest scales, you pretend, you take all the stuff, all the little bumps and wiggles, and you just kind of smooth it out. You're asking what's happening at the largest scales. And we know observationally that at the largest scales, our universe is flat. That means two parallel light rays, if they start out parallel, they will keep being parallel. They won't spread apart. They won't intersect, and they won't get closer together. They'll do it forever. We know this by measuring the cosmic microwave background. We have light that was emitted over 13.8 billion years ago, has traveled through the universe, the width of the universe for 13.8 billion years, and then hit our detectors in antennas. So we can actually look at, we know that the light generated was, starting out parallel. We can ask, did that light spread out? Did it get closer together? And we know this because we look at features in that cosmic microwave background, and we know what size they were when they were emitted because of math and science stuff. That's another episode. We know what the size of those features were, or statistically we know what the size were, and then we can compare to what we see. Are they bigger than we expect, smaller than we expect? Turns out it's exactly what we expected, up to some really, really tiny margin of error. As far as we can tell, we live in a flat universe. Hey, it's me again. I know you just watched a few minutes of me, but who couldn't use a little bit more me? I'm just here to beg you to please subscribe. And if I remember, there's going to be a button like right here where I'm vaguely gesturing so that you can click the button and subscribe, and it's super handy. This is so that you can get the latest updates of all my shows. I mean, that's basically how it works. So if you like what you just saw, you'll get more of it if you subscribe. Super easy.